Okay, we are now in chapter 5, and we're looking at logarithms, or as we would normally say, logs. And here are the two key equations you have to memorize, and these are the ones that are actually flip sides of the same coin. As an exponential equation, if we write a to the y equals x, where a is the base, y is the exponent, and it equals x. We can rewrite that equation, but instead now we're going to write it as a logarithm. So you really have to memorize this. Because what happens is, oftentimes you'll be given an equation with a log in it, and you're asked to solve it. And the main way we're going to solve it is we're going to convert the logarithm equation to the exponential equation. This is called the exponential equation, and this is called the log equation. So normally, if you're given a log equation, the easiest and best way to solve it is to convert it or rewrite it as an exponential equation. And we convert it to an exponential equation, we're able to solve it. So one of the first things that we do in terms of understanding this is to learn to convert back and forth between exponents and logs. So for instance, in their homework you have problems like this. They give you an exponent, 4 to the 5th equals 1024, and they want you to convert it into the log equation. What I recommend you do is you simply define and even write down your a and your y and your x. So if I take 4 to the 5th equals 1024 and compare it to my exponential equation, I see that a equals 4, y equals 5, and x equals 1024. And now, if I take that information and plug it into my log equation, I will now have the answer I'm looking for. So log of base a, and a is 4, x is 1024, and y is 5. So now I've taken an exponential equation and written it as a log equation. Let's do another one. We'll even do one that looks a little more confusing or messy. How about 8 to the negative 2/3 equals 1/4. And I want to rewrite that as a log equation. Well, once again, I can still see up here my a to the y equals x. My a, my base, is going to be 8. The y is the exponent, which is minus 2/3. And the x is the number on the right-hand side, 1/4. And now I plug in the a, the x, and the y into the log equation. And now I'll have log base a, which is log base 8 of x 1/4 equals y, which is negative 2/3. Okay, so hopefully not too difficult. Now let's flip it around. Let's start with a log equation and now convert it back to an exponential. And this is actually a lot more common, what you probably do more often. So, once again, let's write the two key equations, a to the y equals x, now let me take a minute and show you a little shortcut that I found to be pretty helpful sometimes, especially going from a log equation to the exponential equation. Instead of trying to memorize these a's, y's, and x's, one thing to do is, you notice over here, we call this log base a. We call the a the base. Just like over here, a here is also called the base. Matter of fact, let me just make that clear. We call both those the base. What I like to do sometimes, which I saw in a book once and I thought was pretty handy, if I want to take my log equation and derive or come up with the exponential equation, I start with the base, and it's almost like I move in a counterclockwise method. So I write a, I go to the y, and then equals, and I circle back and pick up the x. So the key to that is, you always start with your base, so write your base as the base for like your exponential term, and then you go counterclockwise, the y becomes the exponent, and you go on around to the x, and here you are. So now, maybe I'll even use that method. I could actually, let me maybe show you both methods, and then you can choose whichever way you prefer. So, as an example, log base 4 of 64 equals 3. Now, for those of you who like sort of the old-fashioned method, which is fine, log base a of x equals y, and one way to rewrite that is a to the y equals x. So therefore, I figure out my a, my x, and my y, and I say a is 4, x equals 64, y equals 3. And now I plug those into my exponential equation, and I would have 4 to the third equals 64. All right, so not too hard. However, what I like to do, and I've begun to do this more and more, and I sort of like it sometimes, when I have a log equation like this, instead of having to figure out my a and my y and my x, I just start with the base, go counterclockwise, and then circle back, which translates to 4 to the third equals 64. All right, I didn't have to go figure out the a, the x, and the y. Let's do a couple more. How about log base 12 of 12 equals 1. I'm just going to use my shortcut to write this in the exponential form. So 12 to the first equals 12. 12 to the first equals 12. Let's do one more, see if I can get one a little trickier. This one's got some fractions. Log base 1/8 of 1/2 equals 1/3. I'm using my shortcut. Start with the base, and counterclockwise over here, and end up back at the 1/2. So 1/8 raised to the 1/3 power equals 1/2. Okay, so hopefully you see, with a little practice, it's not really too difficult to be able to convert back and forth between an exponential equation and a logarithmic equation.